this is the question here. So this is our answer here. So the answer is root 5 bracket 8 root 2 minus 3 root 3. So that is how that's how we add or we subtract its sorts. So now this time we want to consider 3 fractions that are solved. So let me navigate it downwards slightly. So you need to pay attention to everything I'm doing here. So the third example that I will be giving you is 5 root 12 over 9 plus 4 root 8 over 6 and minus 50 root 50 over 2. So now we can now get rid of that and let's start. So let me move it here. Now let's start by finding the LCM of 9, 6 and 2. What is the LCM of 9, 6 and 2? So there are some numbers that you need to know their LCM in advance when exam comes around, because if you've memorized the LCM of certain numbers, if you are tested on how to on adding the on adding 2 fractions, or if you are tested or in exam you need to use the LCM of the 2 numbers or the 3 numbers, and you have known the LCM beforehand, then it will facilitate your work, and you'll be able to solve maths quicker than before if you can memorize the LCM of certain numbers. For example, LCM of 9 and 6, 18. LCM and 12 and 8, 24. So you need to know these things. You need to keep it in mind. You need to write it down as well. So LCM of 14 and 21, 42. So LCM of 6 and 4, 12. So when you know this, it will facilitate your work. So you will be able to solve maths as quickly as possible. But not only solving it as quickly as possible, it will make you more efficient and more competent in solving maths. It will increase your proficiency in maths. That's basically what I want to say. So don't just know the LCM of these numbers that you see here, so that for future reference you will be able to use them spontaneously. So that's it. So the LCM of 9, 6 and 2 is 18. So what should we do with this 18? Just as before, divide your 18 by 9. When you divide 18 by 9, you should get 2, and multiply the first fraction by the 2. So you should get 5 root 12 times this 2 here times 2 over 9 times 2, then plus sign, Then again, you want to divide your 18 by 6, the second denominator. So 18 divided by 6 is 3. So 3, multiply it by the second fraction. So you should get 4 root 8 times 3 over 6 times 3 minus 18 again. You want to divide it by 2, the final denominator, the third denominator. 18 divided by 2 is 9. So you should get root 50 times 9 over 2 times 9. So at this point, we need to get rid of everything that is on this side, including the LCM itself. So now we no longer need the LCM. So now let's multiply everything you see on the screen. So what is 5 root 12 times 2? I said that simply multiply this 5 and 2 together to give you 10 root 12. Nine times 2 is 18 plus this sign over here. 4 root 8 times 3. So you should get 12 root 8. Over 6 times 3 is 18 minus root 50 times 9 is basically 9 root 50 over 2 times 9 is 18. So you can see that the denominators 18 are the same. So at this point, let me make space. So at this point, you want to choose one among the 18s and write whatever is at the top. 10 root 12 plus 12 root 8 minus 9 root 50. Now it's a point to simplify the square roots numbers that are at the top, because we can rewrite root 12, which is this root 12 over here, we can rewrite it as 4 times 3 and write it as the square root of 4 is 2. Simply write it as 2 root 3. So now you want to replace the square root of 12 with 2 root 3. There is now how I got this root 4 times 3 is because you want to see if that root 12 is, we can reduce it, just as we reduce fraction. You want to look for two numbers. One will be perfect square, the other will be non-perfect square. So the two numbers are 4 and 3. And 4 times 3 is 12. We know that the value will not change. So this 4 is perfect square, while 3 is not perfect square. So that is why you can use the two numbers. And so if you want to make two square root symbols for the two numbers, you can. But if you want to do it directly, it will make your work faster than if you create two different square symbols. So for now, square root of 4, that is, what are the two numbers we can multiply together? That is 2. 2 times 2 is 4. And we know that 2 times root 3, it simply goes to give you 2 root 3. So that is why I got 2 root 3 here. So you can see what we did here. So therefore, let's rewrite root 12 as 2 root 3. So you should get 10 times, because you want to use times. The 10 root 12 are connected to each other by multiplication sign. So when you see 10 root 12, it's the same thing as 10 times root 12, if you recall it, what I've just done. So there is a multiplication sign between 10 and the root 12. So you want to, now when you do anything to this 12, to this root 12, you want to use multiplications to connect this 10 and the root 12 together. So therefore, that's why I wrote 10 times this to root 3. So now you should get 10 times 2 root 3. Now for this one, now you want to think of how can you break these roots. Let me clear up this stuff first. How can you break this root 8 into two numbers? So you can simply use it as 4 times 2, because 4 times 2 is 8. So simply write it, because square root of 4 is 2. So these two will remain square rooted. So you should get 2 root 2, because these two will never be rendered into whole number. So you need to put the square root symbol on the top of that 2. So now you want to break root 8 into 2 root 2. So you write your plus 12 times 2 root 2. 2 root 2 minus, now you are going to do the same things to the to the last expression, which is root 50. What can you break that root 50 into? What two numbers can you break this root 50 into? Which one will be perfect square and the other will be not perfect square? So those two numbers are 25 times 2, that is 25 and 2. 25 times 2 is 50. It won't change, the value isn't changed. So what we just did was we broke that 25 into two parts, so that one will be perfect square 25 and the other will just be non-perfect square. So these are the two possible numbers into which this 50 can be broken. So now, what is the square root of 25 specifically? Square root of 25 are the two numbers that can be multiplied together to give us 25, which is 5. So 5 times 5 is 25. So you get 5 root 2. So you should know how I got that 5 root 2 now, because this can be written as whole number 5 outside, but these two cannot be written as whole number. So that is why I got 5 root 2. So over here, you want to write 5 root 2. 5 root 2 over your 18. So now let's clear off this stuff here. Then let's continue now and simplify everything that is at the top. Now I'm going to make space, moving it upward. So so at this point, now you want to multiply this 10 and 2 together, because it's the same thing as you see it as a root 2 root 3 times 10. And I said that when you see a number on this side, you need to multiply it with the number behind the square symbol. So it should give you 20 root 2. 20 root 3. Don't forget that you should do the same thing here. Simply multiply 10 and 2 together. So 10 times 2 is 20. So that is 20 root 3 plus 12 times 2. 12 times 2 is 24. 24 root these two here, root 2, minus 5 root 2 over 18. Now, at this point, I would like you to look at the numerator, which is the expression at the top. Is it reducible? Is it factorable? Or what do you say? Can we factorize it? Now, 20 and 24 and 5. Is there any number can we use to divide the three numbers? 20, 24, and 5. Now, 20, 24, and 5, they have no number that we can use to divide the three numbers. If we will use 2, 2 can only divide 20 and 24. If we use 5, 5 can only divide 20 and 5. So, what number should we use then? If we use 1, 1 can divide the three numbers. Or if one divides them, it will not change their value. It will not reduce the value of 20, neither reduce the value of 24 or of 5. So 1 will not work. So therefore, we have any factor or any highest common factor for these three numbers, for 20, 24, and 5. So let's do away with them. But what about the square root symbols? Now let's write root 3, root 2, and root 2 again. Is there any number that we can use to divide these three expressions? Think of it. Now if we take root 3 to divide these three expressions, we will be able to divide only root 3 by root 3. But we cannot divide root 2 by root 3 or this root 2 by root 3. But if we use root 2, now root 2 can divide root 2 and root 2. But we're going to be left with root 3. So root 3 cannot be divided by root 2. Root 2 can only be divided by these two root 2's. So therefore, we do not have any highest common factor as well. So because we do not have any highest common factor, we're going to leave our answer as 20 root 3 plus 24 root 2 minus 5 root 2 over 18. So that is the answer. Let me do that again. So that is our answer for the third example. So now, at this point, you need to be tested on what you have learned so far. If you understood it or you haven't. If you have understood it, these exercises that I'm going to give you, we tell us if you have or if you haven't. So let me show you the exercises. So let me move it slightly upward. But before I move it slightly upward, let me just give you a recap of what I've just taught you. Now over here is the question I gave you on salt. So you can see it here. So what we did first was we look for the LCM, which is also known as, which is the least common multiple of 9, 6, and 2. So the least common multiple of 9, 6, and 2 was 18. And we divided the 18 by 9. So 18 divided by 9, so we got 2. So we multiplied the first fraction, 5 root 12 over 9 by that 2, which was the quotient of 18 and then 9. So the 18, we did the same thing here. We divided the 18, which was our LCM. We divided the 18 by 6. This is over here, and we got 3. So that 3, this is the 3 over here. And we multiply the second fraction by the 3, because the 3 was derived by, from the second fraction, by dividing the LCM by the denominator of the second fraction. So that's why we need to multiply the second fraction by the 3, because the second fraction, because the 3 is derived from the second fraction. So the third thing that we did was we divided the LCM 18 by these 2 here, and the 18 divided by 2, we got 9. So this is the 9 over here, and we divided root 50 over 2 by that 9. So as we did that, we just, now what we did subsequent to that was we multiply what you see here. We multiply 5 root 12 and these 2 together. So simply take these 2 and multiply it by that 5. So, and we got what you see here. And we also multiply 9 and 2. So we got what you see here. So, and we do the same thing here as well. Also here. So whatever we did, we wrote the answer down below. So this one as well. So that's it. And after we have done something like that, we also, we've got the common denominators 18 on the 3 fractions. So we choose one, we wrote it here, then we group everything that is at the top together, which was 10 root 12 and 12 root 8 and 9 root 50. So we group everything here, and remember that we put the positive sign and the negative sign, we put it down right there. So, and you can see what we also, after that, we look, see if we will be able to, to factorize the expression here, but we couldn't, and so that's why we left our answer like we left our answer this form. But we couldn't factorize it, but we multiply this 10 and 2 together. You can do it quicker if you want to, and 12 and 2 together. So you can see that we wrote the answer here. So, and but when it comes to factorizing it, we couldn't factorize this expression here, the expression here. So that is why we leave it as 20 root 3 plus 24 root 2 minus 5 root 2 over 18. So because we couldn't factorize it. So that is it for the recap of what I've taught you in the example 3. But now let me give you the exercises so that you can try yourself of what you have just learned. Now let me glide it. So let's bring in the so these are the exercises. So number 1 is 4 root 5 over 2 plus 6 root 3 over 3. Number 2 is 4 root 6 over 9 minus 7 root 12 over 6. Number 3 is 8 root 8 over 12 plus 2 root 20 over 8. So Number 4 is 2 root 6 over 14 minus 8 root 24 over 21 plus 5 root 32 over 7. So these are the exercises. So you need to do it, and you write it inside your your lesson book. That's a note for maths. You want to write all these 4 exercises on it and do it. Then after you have done it, you also need to take the snapshot of the the writings on your book and write and deposit. That is, you submit it on my WhatsApp page. So I'm going to get in touch with you there by the remarks and marking it for you. So that's it. So these are the exercises. Now we're not going to stop here, because we go to the we go to the more difficult solved problems.